All right, everyone, it is now 2:30, so we can get started. Thank you for coming to class today. This is lecture 6 of Comp 290 and the final lecture of Module 2 on Git. So we appreciate your patience over the last 2 weeks. I know the last 2 weeks have been a little bit more, maybe slightly more dry and more conceptual as we've been talking about Git. We still wanted to really spend a good amount of time on this topic since Git is probably one of the most useful tools that you'll be using throughout every class in the major. So hopefully the last 2 lectures and also this lecture will help you all get a very good understanding of how Git works. And so we're going to be wrapping this up and talking a bit about GitHub today. But first, some announcements. So as you saw last night, A04, which is the GitHub, the Communicate with Markdown assignment, which you accepted on GitHub, we've extended that because there were still some issues that were happening with people trying to accept the assignment and submit the assignment. The assignment was originally, this is an official assignment by GitHub. However, what we didn't realize is in order to accept that, you need to have a valid GitHub student developer account. And getting that, especially if someone started the assignment yesterday or started the assignment relatively close to the deadline, it would have been much harder to get approved for that. So today we're going to, near the end of class, hopefully try and get you all to complete that because the next assignment will be using a similar setup. So if there are any issues, we can hopefully debug them while everybody's here rather than doing it asynchronously. But we appreciate your patience so far. In addition, I think I will show a little bit about what I mean by the student developer account, because I think that even though it seems like quite a difficult thing to get done, especially the amount of times that they reject, if you take a picture of your ID and they still reject you for whatever reason, it seems very annoying. But there are many benefits to this account, and it's something that hopefully all of you will be able to get set up by the time that we finish the semester, and hopefully by the next assignment. But the idea here is that the GitHub student, they call it the developer pack, but also this comes with any of the developer accounts. There are many different things that come for free to students if you have this account. The first one is what they call experiences, and these are kind of like these courses or self-guided activities on a large variety of topics. So you can see that they have different things like GitHub. There's a GitHub certification here. There is AI prompting and technical writing. There are things like career readiness and intro to web dev, mobile app development, data science, communicate using Markdown, which is exactly what you all were working on last week. And there's many others here which are really useful. So if you're interested in potentially learning about any of these topics, this is free for students through GitHub. In addition, there's also a lot of different offers that they provide to students which help you to get discounts on various things. For example, sorry, I think I'm scrolling. Oh no, this is right. Okay. So there are things such as Notion. There might be a discount here. I know GitHub Copilot. You can see you have free access to GitHub Copilot as a student, which is really, really nice because otherwise it does cost money. There are things like JetBrains, so if you're in Comp 210, you're using IntelliJ, I think, unless the new teacher changed it to Eclipse, I don't know. But if you're using something like IntelliJ, you can get the professional version for free. Microsoft Azure, this is something that we may talk about later, especially as we move into the side projects piece. But there are free access here and $100 worth of credit. So there's a lot of really great tools here that they offer and discounts for you as a student. And so that's why we hope that everyone will be able to get on this account because there are some really great things here. All right, any questions here about this? Okay. And then to continue on announcements, A05, which one is A05?
A05 is just like Git, very basics of Git and sort of creating commits and merging.
Great, thank you, Noah. So A05, that will be due on Monday. This, again, should also be relatively short. If you have any questions, please tell us either in an email or on the Canvas discussion board, and we can help to answer those questions. The last thing, hopefully you all saw on the announcement that went out, I think on Wednesday or Thursday, there is a survey. And this survey will help us as we continue to iterate and work on this course We appreciate it so far. We have around, I think, a little bit less than half of the class has filled out this form. This will be worth an attendance grade, not based on how you fill it out, but just by filling it out entirely. So you can reply in any way you like, but we are going to count it as 1 point. So please try and complete the survey. It's really helpful to us. We will try and have 2 more surveys, one at the 2/3 mark of the class. This is at the 1/3 mark of the class, and then one at the end of the class. So please fill this out. We greatly appreciate it. It will be due tonight at 11:59. It should take less than 5 minutes to complete. Any questions here? All right. In addition, there are a few announcements, community events and announcements that we would like to share with everybody. The first one is I'll actually talk about the one on the right first. So this is called Meet CS. It is a mixer and an event for undergraduate students interested in applying to the CS major. So I think that applies to most of you all in the target audience. So that includes students in Comp 110 or students in Comp 210. There are, I think, free insomnia cookies here, so recommend attending. They'll be talking about the CS department, different resources, how to become more involved in the community, and also information about the application process. This will be, I think, on Friday at 3 p.m. I know it seems like it's kind of the middle of the day, but it does go until 4:30. So even if you have a class at some point, you may be able to attend either the first or second half. This will be in Sitterson, room 11, so SN 11, and again, Friday. So I don't think that there's any specific sign up for this. You can just attend. So mark this in your calendars, and we recommend that you check this out. In addition, something here on the left is a program that is offered by the student experience ambassadors here for our department, and these are coffee chats. So you can talk to one of the ambassadors, and they can provide great information, great tips, and great resources on various things, such as internships, different classes, potential research opportunities, clubs, and mentorship. It is a great way to connect with some upperclassmen in our department and to become more involved and to learn more about the different things that our department offers. And you can sign up at your leisure, so depending on whenever you are available, you should be able to fill out this form and they'll be able to schedule a time with you. So we recommend both of these events. In addition, as you can see in the front of the class, there are different flyers we have put out, so if you want to scan it after class 2, feel free to come up. Any questions here? Great. And then the last 2 pieces here are a recap of the last two announcements from great people within our student organizations who came. First, we have the Carolina Data Challenge. This is, I think, happening, is it this weekend? This weekend, yes. So it's still available to register. This is, again, a data science hackathon. It's open to people who are absolute beginners. There'll be good networking opportunities and workshops to learn more. So if you're interested in signing up, the QR code is here. Again, this will be this weekend. So this will probably be the last few days to register if you are interested in that. In addition, Hack NC, which is the largest hackathon here and is, I think, in the entire region, this will be a great opportunity as well. There are a lot of many beginner workshops, and we highly recommend that you all attend. There's a link right here. Please sign up if you're interested. There's a lot of great opportunities there, not only to meet people who are in your year and might be interested in working in a project, and also just learning more about computer science. Any questions about any of these 2? All right, great. So with that, I'll hand it off to Noah to talk a little bit more about GitHub and how it relates to software engineering.
All right, thank you, Ajay. Also, Ajay did not mention this, but he ran Carolina Data Challenge for a year at least, so it's a good event. Check it out. But yeah, okay, so let's start where we left off last week. Up until this point, we've only been talking about Git, right? You've heard of GitHub. You might have even seen it for your classes, but really we've just been in the command line with Git. We haven't touched GitHub. And so we have this idea. This is just the diagram that we started. I'll refresh a little bit. Every one of these circles is a Git commit, remember, and every commit just points to its parents. And so we have all these histories of commits here, and these tags that you see are branches. And that's sort of everything that comprises a Git repository. It's how we keep track of our changes in our code, and that's Git in a nutshell. But up until this point, our examples have just been on a single computer, one single person working on their code. So naturally the question follows, what happens when we want multiple collaborators, right? Because rarely do we write code, especially in industry, that's just by one person. So this is where GitHub comes in, and it allows fundamentally just collaboration with Git. So it lives essentially on top of Git, and whereas before, you notice here there are no profile pictures. This is a single person setup. This is just locally on my device. Now we have many people working together, me, Ajay, and Chris Jordan apparently. So now we all have our own little things here. Maybe I'm working on feature B. Ajay's also working on feature B, but on a different area.
Yeah, that's a typo. It should be feature C.
Feature C, sure, yeah. Right, because, yeah, you wouldn't normally have two branches like that. But, and then Chris is off working on feature A. But the point is that you can be at totally different areas. You have your own copy of the code. But at some point, we're going to want to share it down the road when we bring it all back together. And so that's where GitHub comes in. It just allows us to store and share Git repositories in the cloud. So remember, a Git repository locally on your computer really just lives inside a folder. That's really what it is. So GitHub at its most basic thing is just like file storage with a whole bunch of features on top of it. But with GitHub, it's a website that lets you share code, collaborate with others, right? Anybody, well, okay, there's limitations. You add people to your repository and then they can collaborate on it. Most are not just allowing anybody to contribute, but the idea is that multiple users can contribute to your repository. It has this very useful bug and issue tracker that's totally just a feature of the website, not of Git, and we'll get into that. And crucially, I think this is one of the most important parts down here. It lets other people review your code before you merge it. So remember before, when we had two branches, we were able to just merge them back into each other whenever we wanted to, and it was totally on our whim. We decided how to resolve merge conflicts. We said, just do it and now push it up, or commit rather. But when you're working in groups with a lot of people, right, you might not fully understand the code. You probably have written a bug or two at some point in your code. So you want other people to come check and sign off essentially. Say, yeah, I've looked at your code, it looks good to me. Or, oh wait, you sort of missed this part, you might want to fix this part. And that's what GitHub really streamlines. So this is something really important. Before we get too much into GitHub here and into some demos, really understanding the difference between Git and GitHub. So Git itself is the version control tool. It is what is making these commits. It's how it relates all these commits together. It is how you interact with your files through the command line. That is purely Git. GitHub is totally a separate website that just stores Git repository and allows collaboration. So like I said before, basically a file host sort of service. But it itself, I think this is one really clear distinction. GitHub, anything that you can do on GitHub to a file or to your repository, you can do with Git. It doesn't fundamentally allow you to do anything differently, or let me rephrase that. It doesn't do anything that Git can't on its own. It changes the process sometimes, so instead of just directly merging code, like with Git, through GitHub you make a request for someone to review the code and then get merged. But fundamentally the merge you could just do on your own if you want to do with Git. So remember to keep those really separate. GitHub is a website, it's a separate service. Git is the version control tool. And we don't even talk about this in here, but there are also other services like GitHub. There's one called GitLab, there's one called Bitbucket, and they all essentially serve the same purpose of being like a sort of a cloud provider. There's somewhere where you can put your Git repository to share with other people, but underlying all of them, they use Git at their heart. And so what we'll end up seeing is sort of a key takeaway from this is that when we have a local Git repository and a version on GitHub, there might be a mismatch because maybe we made changes here that don't exist on GitHub, or there's changes on GitHub that differ from our local. And that's totally okay. That's how it's supposed to work, and we'll see that sort of pan out here in a second. Sorry, any questions up until now? Any clarification needed on the distinction between Git and GitHub? How's everyone feeling? Do you think you know what the differences are? Thumbs up, thumbs middle, thumbs up. Okay, cool. All right. So here's a quick little example of what you might see that's different. Sure. Yeah.
There we go.
Thanks.
All right.
Great. Okay. So this is, like I said, your GitHub might differ from your local, right? Because they're There's a copy of the Git repository in GitHub, and then there's a copy on your machine. So here's my machine's copy, and we see we have feature A, production, feature B, and then we have this one on GitHub, also production, feature C, feature B, but they're in different orders, the branches, right? There's feature B here that doesn't exist on my remote. There's feature C on GitHub that doesn't exist here. So there's these differences between the two. So this is sort of building off of where we stopped last time. So with Git, right, you have a local repository. That's what we did. We created something on our machine. It only existed on our machine. But now we want to add it to a GitHub repository so that we can share it with people. And so in Git terminology, our local repository is just called local because it's on our machine. And there's a repository in GitHub, and that's called the remote. You'll always see whenever you read any GitHub documentation, it's going to call or any Git-related documentation, the repository that's on GitHub is going to be called the remote, and then the one that's on your machine is called the local. So just make sure to really get that terminology down. And the remote is something, just anything that's, or the website that's external to your computer, whereas local is your computer itself. And so when we start a Git repository, it only exists on our machine. But there comes a time when maybe I've gotten it to a point where I'm like, okay, now I want to share it with Ajay. Now I want to share it just with anybody who wants to read my code. Now it's time to basically add a remote. So there's this concept in Git of you can create just a local repository first and have it totally separate from a GitHub repository. But if a time comes where you want to add it, you just create this repository in GitHub, add it as a remote, basically as a place where I can store my code. And then we tell Git, okay, push my code up to GitHub. And that's what some specific commands we'll see here in a second. So this command specifically right here is what you use to add one. So we're in our Git repository, we've made some commits, we have some sort of history, right? And then using this, which we'll see again here, so you don't have to get it immediately right now, but we say git remote, add origin, and then some sort of URL. And so origin is convention in Git for the sort of default remote repository. So there's this idea that there might be multiple remotes. Maybe you have, for some reason, you have two Git repositories. Can you think of a use case for that at the top of your head?
Yes, actually, one use case which you'll see in later classes as to why you may connect one local repository to two different GitHub repositories could be with assignments that are given by a professor. So if you're working in a group project with 4 different people, you may have your team's work as one repository, but then you may have the template or like the starter code that the professor gave you as a different repository. The reason why you may have this set up is because say that there was an issue in the starter code that the professor gave you, the professor can update the code on his side, and you, since your local repository is connected to both your team's repository and the teacher's repository, you're able to update your local code with the changes that the professor made. And so you'll see this setup. It seems it's a bit hand-wavy, a bit abstract right now. In later classes, you will see that professors may use this setup, and I think even in some 210 classes, I know in the past this was a similar setup to how they did it. I don't know if that's changed. Same with 301, but in classes like 423, the first software engineering class, that is the way the setup is. The professor has this repository, that's the starter code of the assignment. Every group will have their own repository, and both of those are used as different remotes.
Cool, thank you. Yeah.
Any questions with that explanation there? All right.
Cool. And so with this remote and your local repository, you'll notice once again when reading a lot of Git documentation and whatnot, there are these very specific verbs that we use. So here's a quick description of them. Push, fetch, and pull are the key ones. And these fundamentally just mean, how do I interface with my remote? And these are some great slides by Ajay. He's gone ahead and color-coded these here to exactly what they do in the visual diagram. So if you look at push, this is the green one. It says upload changes made locally to GitHub. So pretty self-explanatory. I've made some changes. I've maybe committed, made some branches, whatever. Any change to my local, put it up on the repository in GitHub, put it up to the remote. And so you see there's this arrow here that just pushes it straight up there. Fetch and pull are a little different in that you see they're both arrows coming down, but one is dotted, one is solid. And the reason for this is fetch just means retrieve the latest versions from the project on GitHub, but don't actually change where I am locally. Don't overwrite my changes. So this is sort of like fetch. I like to think of it in my head as sort of like a soft pull. Like it takes the changes, but it doesn't affect what you're doing. It just syncs you, so that if you do want to change, you have the changes locally to reference, but it doesn't overwrite what you're doing. And so we'll see this in a second, what the actual difference between fetch and pull is and how it affects your local repository. But just keep that in mind. Fetch just gets it, doesn't overwrite, whereas pull will actually take the changes, pull them down, and merge them in to your local repository, meaning that if you have some changes that are conflicting or whatever, it's gonna give you a bit of a hard time. It's gonna force you to change those. So yeah, that's what pull is. And if we go ahead now, we'll get into the example of this. So for this, I'm actually going to, let's see.
Also, while noticing, any questions on kind of the difference between pushing and pulling? So again, if you're using, I think a good way to think about this, which is maybe slightly more grounded in something that you all have used, is like with Google Drive. With Google Drive, whenever you want to upload something, right, you have to either drag it in, there's an upload feature, and then it puts your files into Google Drive. That's a very similar idea here with pushing. We're taking something that's on our computer and we're uploading it to the cloud. Pulling is kind of the opposite, where you're downloading from the cloud. So a way you can think about this is you may have a Microsoft Word file on your computer. You make some changes and then you upload it to Google Drive, and then someone else who has access to that same shared folder can then download the file that you uploaded. It's kind of a similar idea there.
Yeah. Okay. So to get started here, we can see I'm just in this Comp 290 folder, just sort of where we do some scratch work. And let me go ahead and ls here. Let me take a look at my files. This is not, sorry.
Go ahead.
Yeah. This is not something you have to follow along with here. I just want to sort of do this demo so we can see these Git commands in live time.
Okay.
Cool. All right. So
Wait, that one is a
can I bring
bit.
that one down a little bit?
Yeah, there we go. That way they're somewhat visible to the back.
Yeah.
Okay.
Good call. Okay, cool. So, also wait, sorry. Do you mind if I make a GitHub repository on your account?
Yes.
Okay, cool.
Go ahead.
Great. Okay, so we'll get to that in a second. So let's go ahead and make a new folder. Make sure these are aligned. That's good enough. Okay. So I'm going to go ahead and make a directory. Remember, that just makes a directory, makes a folder in here. And for this example, I'm going to pretend like these are two different machines. So essentially, right, this is only one machine that we have up here right now. But when you're actually working in practice, you're going to have two or more people that are sharing a common remote. I'm making code, I'm writing my change, I'm uploading it, I'm pushing it, and then Ajay some other time wants to pull it down, download my code onto his computer, and see the changes there. So to demonstrate this, I'm actually just going to make two totally separate repositories here between the two. And they're going to just share a common remote. And so I'll show what the actual process of that is in a second. But for this, I'm just going to make a directory, and let's call it Ajay. And if I ls, here it is. So I'm going to change directory into Ajay. And now if I pwd, our current working directory, right? Okay, perfect, we're exactly where I want to be. And in this one, I'm going to make a directory, and I'll call it Noah. And I will change directory into Noah, so just changing where my terminal is right now. And now if I print the working directory again, we'll see we're in different locations. This one's in comp290/Noah, this one's in comp290/Ajay. And so I'm going to go ahead and just clear the screen here to reset us. And so for this example, right, I want to imagine these are two different machines. So let's go ahead and initialize an empty Git repository on both of them. So here I'm going to do git init. Remember, this is just how you initialize. You're in an empty folder. This is how we initialize the repository. And now we have a repository inside of Ajay. And if I do the same here, we have one here inside of Noah. So these are two totally separate repositories, and we can show this here. I'll go ahead and just make a change to this repository and make a commit. So we'll have some history. So let's go ahead. Remember the echo command. This was used a lot in previous examples where I can just give it some text. I output redirect it, and I give it a file. So let's say file.txt. So I go ahead and run this, and if I ls now, list my files out, great, we have file.txt. And if I go ahead and run the cat command, remember this just shows you the contents of a file, cat file.txt, we have some text, great, so it worked. So now we have some change here, and I'm gonna go ahead and clear my screen. And so remember, when we wanna make a commit, there's a sort of two-step process. We have to add it to the stage, and then we have to commit. So to even see the status of my files, there's the handy git status, and this will tell us. On branch main, no commits yet, untracked file, because we haven't told it to track this file yet. So remember, use git add to track. So we'll do git add, and the convention is just git add period, which means add my current working directory. And so that's all we've done here is now if I run git status again, the status will have changed. It went from being an untracked file to being added to now it is a tracked file. So if I commit, the commit will contain this. So I'll go ahead and do that. Remember, just git commit, and then we pass a little message. First commit, how about that? And if I run this, this will just make a commit on this local repository. Why is it giving that? Okay.
That happened before. I out of space.
Oh, okay, there we go.
Sometimes.
That was also happening on my computer too.
Yeah.
It's really weird. But okay, great. Now we have a commit, and to see that this has been done, remember the git log command. Sorry, this is a lot of git commands, I know, but these are all sort of crucial ones. So all I've done so far, I've made a new repository, I've added a file, I've committed it. And now I just want to see that in the logs here to prove to myself that I've done that. So remember git log a dog. So all one line. Oops, that's going in the wrong order. Sorry. Okay, A for all, decorate, D for decorate, O for one line, and then G for graph. So git log that. And here we go, great. Head, main, first commit. It's all very simple here. And if I go over here, remember I initialized, now I'm on my other machine. Remember, think of this as a totally different computer. I'm in this repository here. And if I go ahead and run git log all one line, decorate, I was doing the wrong order. One line, graph, right? There's nothing there because I haven't done anything. They're totally disconnected at this point in time. So now I say, okay, I've made my changes. I want to put this on a remote on GitHub so that Noah over here is able to pull his changes and work in his repository and we can collaborate. So to do that, the first step is just going to be going to GitHub. We'll see here. So we're in GitHub, and there's this nice little button here, new repository. We're just going to create one right here. And there's a lot of options here, so it's a little weird. All we need for now is just a repository name. So I'll call this Lecture 6 Demo. And great, it's available. We can do a whole bunch of stuff here. We don't need it right now. We just need to make sure it's public so that anyone on the internet can see this repository. So that when I share it with someone else, it's easy. Otherwise, if I make it private, I have to go through a whole process. And I'll go ahead and create this. And now we get these really helpful instructions from GitHub saying, okay, you just made this repository. What if there's a situation when you have an existing repository on your machine and you want to push it from the command line? They very conveniently give us the commands here. They have some for a different situation where we want to create a new repository. And so we'll focus on these down here at the bottom. And they actually give us more than we really need here. So I'm going to change up a little bit of what they're doing. But the first command is git remote add origin. And if you remember from earlier when we were talking about this, this is just how you add a remote repository to a local one. You use the git remote add command. So we'll go back here. And we'll do git remote add origin. Let me make this bigger so I can do that. Actually, I think I copied the whole thing, so I'll just paste it in here. But let's break this command down too, right? This is saying get remote. We want to add a remote, and we want to call it origin. That is just the convention of the ordering of these arguments, because sometimes you might want to delete a remote too, so then it's get remote remove, or you want to rename it, get remote rename. So this is just the order that they have to go in. Get remote, add, call it origin, which is convention, and then here's the URL for our GitHub repository.
I would like to add real quick that here you may notice that this, we were talking about how we're naming our remote origin, but you probably noticed on the previous page that the name of the repository was not origin.
Yes.
Right, so if you go back here onto GitHub, this here was called Lecture 6 Demo. So it is important to keep in mind that the name that you supply for the remote is actually just a label. It's a label, just like how a branch is a label to a commit. When we have a remote, it's a label to an external repository. So you can name that remote in the command line whatever you like, and it can be different from the repository that you put on GitHub. Right, that's all.
Yes, no, I think that is a really important point, yeah. The reason you'll just see origin used everywhere is just because that's sort of the default just within Git convention. But yeah, it could be, I could name it whatever I wanted. So I'll go ahead and run that. Just doesn't actually output anything, but we can double check to see that we've added it here. We do get remote and just pass it this -v argument. I think it means like verbose or something. What it does is it lists our origins or our remotes out here. It says, here we have, oh, that died. Okay.
No, that's back. Yes.
It's back. All right. It says here we have two remotes, origin. They're both called origin, but where they differ is, look over here. Here's for fetch and here's for push. And so this is actually what you'll see anytime you use the get remote add command and add anything. It's going to add both of these because one of these, the push, remember that's uploading. One is fetch, which is like downloading. It just keeps the same name here. It says, okay, we can push to origin or we can download from it, right? If you use it in either case, origin's going to work. But there could be situations, if we go back to Ajay's example, let's say professor puts up some starter code that we want to pull down. We might only want to add it as a fetch because we're probably not going to have permissions to edit the original starter code. So you can add an origin purely as a fetch location or purely as a push location, but just by default, you'll get both. And that's what we want here. So I'll go ahead and let's tell our code. Now. So if we go back, we haven't actually done anything. We added it to our local, but you can see here, GitHub still doesn't know anything about our repository. It's in its default state. So if we come back here, now we want to upload our files. So remember the command for that is git push. And this is telling Git, okay, now we want to push these files up somewhere. But we want to specify also where we want to do that. So that's where this origin name comes in. We say git push origin, so now it knows where it should send the files. And we'll also append this right here, main. Main because that is the default branch that we're on. So you specify the branch that you want to push up. You can also do a thing where you just push like all your branches, but in this case, because we only have one branch, just main, I'm going to be verbose here and specify all of that. So I'll go ahead and send that up. And there we go, great. It says writing objects, it sent it all up. And now, if we come back and give this a refresh, we have something. This is a repository with file.txt. If we look at it, oh, there's some text. That's what we put into it earlier. So now it's initialized. We have a working repository on GitHub. If I send this link to anyone right now, they can come, they can look at my code, they can download it, interact with it. So this is great. So in this hypothetical, now Ajay says, okay, Noah, I uploaded my stuff to GitHub, come work on it with me. And so he's gonna go ahead and send me the link, right? And I come over here and I will now say, okay, I now need to interface with this remote. But in my repository, if I get remote -v, remember this just lists all the repositories. This is Ajay's on the left, this is me on the right. Oh, I don't have any remotes yet. So I have to go through the same process and I need to add the remote for myself. So remember, get remote, add, name it. I'll also name it origin here. And this is actually, in this situation, right, these are totally separate machines. I could call it whatever I wanted. I could call it Ajay origin or something, and it'd work totally fine. This is totally local to my machine. And now I need this URL again, which I'll just copy out of here, paste that in, and now let's go ahead and do that. So it's added the remote, but interestingly here, let's take a look. So remember, this on GitHub, this single commit exists in our history that adds this file. Let me look at mine real quick, and let me run. Actually, I'll just use the up arrow here. I'm going to come back to git log. Remember, this is just going to tell us everything that's in our history, our Git history. Oh, there's still nothing. Well, that's weird. I just added the remote, but the changes have not populated. Remember, that is because Git is not automatic. There's some really useful services like, the file helper for like OneDrive. You put a file in there, automatically uploads it to OneDrive. You put a file into OneDrive, it automatically downloads it. Git does not do that. You have to be very explicit with Git. You have to tell it, upload this here, download this from here. It will not do it automatically. So, in that case, we are now going to have to tell it, okay, Git, we want you to go get Ajay's changes, download them, and similarly, where do we pull from? We have to tell it. We want to pull from origin. What specifically do we want to pull? Well, since we have the main branch up there, let's pull our main to match our local. So I just run this. We're telling git pull the remote name and the branch. That's the structure. And there we go. Now we see, okay, it's gotten some objects, total three. It's unpacked them, put them in our local. And now we see there's this from the GitHub URL. We have some new information here. So let's go ahead and run git log again. And this is great. Now we have this commit on our second machine here. Now, actually, if I run, this is something. Okay, now we're back on Ajay's machine. Let's also run the git log command. Remember, this is just looking at what we have. Okay, perfect. Now we're perfectly in sync. We're at the same location. So in this situation, at this point in time, actually, Ajay's machine, my machine, and the remote all match each other. But let's say, now Ajay's gone off to bed. I want to work on this. So I'm going to go ahead and say, okay, let's do echo another one into second file.txt. Very creative naming conventions, I know. But remember, this is just going to make a file called second file. It's going to put the text another one in there. Let's do that. And now if I ls, let's look at my files. Oh, great. We have second file. And if I cat that, and just remember, this just looks at the contents of the file. It says another one. So great. We have another file. And just to make this a bit clearer, I'm going to go ahead and run the clear command, so refresh terminal. So now I'm going to commit this. And remember, committing two-step process. Let's first look at the status of our Git repo. This is just a good way to orient ourselves. We see, okay, untracked file. We need to use git add for that. So git add, period, just says add every file in my current directory. That's changed. Let's git status again. And there we go. It's ready to be committed. So, and sorry, I know this could be a little tedious. You're seeing us go through the stages of committing every time. But the reason is because this should just it's important to sort of get this down as muscle memory. Just the git add, the git status, git commit. It's going to become so important to you that being exposed to it a lot, I think, is a good thing. So you get really used to just doing it without giving it a second thought. So we'll go ahead, and now we'll make our commit, and we'll say, here's another file. And remember, git commit, just giving it a message so that there's some data with it. And great, now it's there. And so I'll go ahead and look at my git log here. And okay, interesting. Now we have these two commits. Here's our original one. Here's the one I just made. But you'll notice there are some differences here. So my local head, remember, head just tells me where I'm oriented in my local Git repository. And it's pointing to main. And my main branch is here, on here's another file. But if we look at origin main, it's still pointing to first commit. So you'll see this sort of convention a lot when interfacing with remotes. You have the remote name / the branch name. And so this one without anything before is your local branch. This one with the remote / branch name is the remote branch. And what this is telling us is just, okay, like there's no problem here. It's just that I've updated mine locally, but origin has not been updated yet. Origin doesn't know about this. So let's say here, okay, I want to send this back up. I want to collaborate with Ajay when he wakes up in the morning. So we'll do git push, just like we did originally. We're saying, okay, time to push our changes up. Where do we want to push it to? Our origin remote. And we want to do the branch main. So I'll just run that here, and all this is going to do is take my changes I made here, put them back up on the repository on GitHub. So I run that. Great, no errors. And now let's run git log again. Great, so now the difference is origin main has also been updated. It says my latest changes have made it up there, whereas before they were only on my local. Now it's all nice and synced. So this is great. Now I've done my work. I'm off.
Real quick.
Sorry, yeah.
We can also see if we
Oh, yes.
refresh. Yep, that second file is now uploaded. Yep.
Fantastic. And if we look at 2 commits, here's our little commit history, just in another nice little UI. Okay, so now I'm done I did a lot of heavy lifting there. Now it's Ajay's turn to take over. He's back up, and remember, let's say he gets on and just runs git log. It's the same thing. Remember, I only updated from my machine here. Noah's machine, it sent everything up. It's in sync now with GitHub. Ajay has not synced any time. He has not touched this since he last uploaded his code. So now we have to remember, Git is not automatic. That is something I want to stress over and over. You have to tell Git to pull changes. You have to tell Git to upload changes. It will not do it automatically. So let's actually say, okay, I don't know, let's pretend maybe I made some changes as a J, and now I'm not sure if Noah's stuff is going to conflict with mine. This could be a bit of an issue. Let's just see what happened while I was gone, but let's not overwrite anything. So remember, that's where this difference between fetch and pull comes in. Pull, if I just get fetch pull right now, it's just going to take it, it's going to overwrite what I've done. Or it's going to try to, and it'll error out if there's something there. If I just get fetch, it's just going to see what's been done, but it won't overwrite anything. It's pretty safe. So let's do git fetch. And we see it's gotten some data here. And let's run git log again. And now, interestingly, we actually run into a situation that's sort of opposite what we had here. So if we look at my machine, this is Noah's, right? Originally, before we pushed it, origin main was back here, and our head was updated because we made that commit locally. But now we come over to here, to Ajay's machine, and it's flipped. Origin is now up here, but we're behind locally. So there's a few ways of telling it to update here. There's various commands. You'll find in Git a lot of times, actually, there's multiple ways to do one thing. But for the sake of this, I'll actually just do git pull and show you how this is going to affect our local. So I'll say git pull, remember, and I have to tell it where, give it the remote, origin, let's give it a branch, main. Let's do that. And now we see it's done this thing. It says updating, fast forward. Should we get into a fast forward, do you think?
We'll wait.
All right. So yeah, just essentially if we run git log again, remember all I've done now is I've pulled from my origin. Let's look at the log. Oh, great, now it matches. Now my local head and main are pointing at what origin main is pointing to. Remember, totally separate. Origin main exists only in GitHub. That's what GitHub's main is pointing to. This is my local main here, and now they're synced up.
I'll just just to very briefly talk about what fast forwarding is. You'll just see that fast forwarding is the idea of one branch, such as in this case, head main was down here, and it just forwards up and moves forward to another commit. The specifics behind how all of that works will be a future thing. But,
yeah. It's nice when you're able to fast forward. It's probably the easiest way to do things. So, so now we're up to date, and that's really all I had planned for this demo. There's a lot more we could do. We could create branches, right? Sync those branches up and down, which maybe, I don't know. I want to get onto a little bit more in the class, but that's the idea. And so, And so this is sort of the workflow that you're going to see. When you start working with people, when you start collaborating on projects, this is the flow that you're going to go on. You're going to make your changes, you're going to push them, and then when you get back on to make changes later, you're going to fetch, see what changes have been made, pull in the ones that you want, and continue working. And to sort of visually diagram this, actually, I'm going to try this out. Pilot draw, okay. We're gonna see how well I can write with this, but essentially what we've done here is we have this sort of cloud here. This is GitHub, okay? GitHub, okay, we'll abbreviate it. And what we had was my machine and Ajay's machines down here. So that is a weird looking laptop, but that's Ajay's machine. And here's my machine. Oops. Cool, okay. And what we've had here is we've set up basically a two-way street between each one. So initially, remember, Ajay uploaded his changes. That is really bad, oh my God. Okay, Ajay uploaded his changes, and then he said, okay, go to GitHub and pull them from there. So then I pulled those changes. And then I said, okay, I made some changes. Let me upload them from here. And then Ajay got back on and said, okay, let me pull those. But you can see here, this is, right, there's nothing that's limiting us to two. We can get whoever we want on here. All we need in common is GitHub. And then another third person, fourth person can hop on, start a two-way street with it, upload code, download code, whatever they want. And similarly, there's nothing from stopping me from having multiple remotes here. So maybe I have another sort of remote here, which is, I won't even label that. But let's say, okay, I'm also going to use this as some code. Maybe this is like starter code that my teacher gave me, right? So you can see there is no limitation in either direction of what you're connected to. You can have many remotes for a single repository. You can have many locals for a single remote. It's really just however you want to set it up. But that also makes it very powerful. And actually, this is a kind of interesting aside. We can even go directly between the two computers if they're set up correctly, which could be a little dangerous, a little bit of a hazard if I have access to Ajay's computer like that. But this is how some things are set up, where maybe I have, let's say, a server, and I actually just want to be able to directly upload code and download code from there, and I don't even want to mess with GitHub. That can be done, but that's a little bit much. But this is fundamentally the relationship between your local and these sort of cloud, mainly GitHub. That went better than I thought, drawing-wise. Cool. So now that we've done that, now we've seen sort of how to use it at its core, right? GitHub at its core is just a way to share these files that's Git compatible. But now we want to take a tour of the website. Let's see what else GitHub has to offer here. So let me actually open up these slides here so I can follow them. At a very brief level here, let's just look at this repository that we created. At first we see the code. This is just sort of the core. If I had to split GitHub into sort of sections, right? This area right here, that's the core repository. That is all my changes. It sort of encapsulates all of my Git stuff in one thing. Here's the people that are making changes. Here are the commits. Here's data about the commits. That's everything. But then beyond that, we have these sort of features of GitHub. And one of these things that we mentioned earlier is this thing called issues, right? An issue tracker. So let's say I found a bug in the code, but maybe it's someone else's code. I don't really understand it. So I'm just going to leave them an issue. I'm going to say, this is how I created this bug. Maybe you want to deal with it. Maybe you don't. There's this other tab called pull request, which I'll actually come back to in a second. But this is the key, sort of the key tool on GitHub. This is what I was talking about earlier when I said this is what allows you to interact with other developers really well. When you say, okay, I want to merge my code in, or I want to make some change, can you double check me? And I actually really hate that the naming convention is a pull request on here. It's very sort of misleading. You think it's a pull request. Does that mean, am I requesting to pull the code? I like to think of it in my mind as a merge request, just saying, can I merge my code in? And it's not populated here. Sorry, Jay, do you want to add?
Can I show the Excel?
Yeah, I was about to say.
One repository. So this is a blank one,
Yeah.
but I will show you an example of one that is very heavily used. So I've gone to this site before, but this is the repository for the CSXL website. So the website that you go to book rooms above, that is also all public code, and that is in GitHub. And so when you see it like this, when there's a lot more code, there's a lot more features, you can see how these features of GitHub are utilized. One of them here, as Noah was talking about, was issues. So again, this is a list of all of, for example, different problems. Like you can see there's a bug here. There's some tasks for some TAs to do. For example, I'll open one. This is an issue, and issues allow somebody to write a bit of a description about what might be going on. So you can see that yesterday, Chris Jordan said that there's an issue that for certain classes, we're trying to sync the roster of a class into the website, and there's a problem when you do that if the instructor has started to add grades into Canvas. So that's just a bug that's happened. You can see it says here that Chris Jordan has made a comment. Here's some I guess a explanation of what the problem is, and also maybe some potential ways to fix it. You can also see here that he has assigned under assignees. This is basically saying that, all right, I as Chris Jordan, I'm asking for this person to fix it. So he's put me there, which means that I'll have to look at this later. But this is a very cool collection, or this page is very cool because it allows you to really streamline a lot of processes that as a developer may have been in different places. So fixing problems is one. In addition, there's a really cool feature here called projects, which I'll just very briefly show. And projects basically just allow you to lay out issues in a very nice visual way. So these are all, just like that list before, those were issues. These are also issues here. They're just in a different orientation. They're going in these different columns. And you can see, for example, here are all the different things that have been completed recently. Here are some of the things that are currently in progress. Actually, I'll move this one. And so you can move them in between these different columns depending on how far along you are working on certain things. And so this is a really cool feature that, because when you're working with a lot of people and you're working on many things at once, this is a great way to keep organized. And this is also, all of this is free, which is a great piece of great thing with GitHub is you don't have to pay to use like projects and something like that. And also, as Noah was talking about with pull requests, and I'll hand it back to him in a second, here is an example of a current one. So you can see actually, do you want to explain this?
You probably know a bit.
All right, okay. So pull requests, as Noah was saying, this is kind of it's better to be thought of as a merge request, because what's happening here is these group of people, which I think are two of the TAs for 423, they have worked on something and now they want to take what was in their branch, which was called, you can see right here, room reservation capacities, and they want to merge it into main. Now, the thing is that since this code is public, what is on the main branch, this is what is currently live on the internet that users can see, right? The process for how that works, we'll be getting to that in a future lecture, because we will actually be talking about uploading stuff online. But here, you can assume main is what's on the internet, what users see, and they want to take what the code that they worked on and upload it and combine it and merge it into this main branch. Right? And as you can see, this is the reason why we might need something like a pull request, or as Noah was saying, a better way to think about maybe a merge request. Because in a very large project, let's say there are thousands of people, I know that for a fact that there are, I think, 900 people who are currently have an account on this website. So if any developer could merge their work into main without asking for approval first, right, there could be a lot of problems. Somebody could accidentally delete a feature, they could make a bug that breaks the site, whatever. So it's very important that before they take the feature they worked on and add it to what everybody can see, that it is approved and looked at by somebody. And so you can see here that this is an example. So this group created a feature, they wrote a little bit about it, and then you can see down here, right, I commented here, I said this is looking great, and then I gave some suggestions. So you can see that I, for example, added a comment here, like they can remove this comment from their code. Here, right, there may be a better way to do this to prevent errors. And this is a great way for developers to communicate with each other, collaborate, and also to get their code reviewed by somebody who has maybe been working in the code base longer. So if you're working in an internship or something, you'll probably be opening pull requests, and your boss or your mentor will probably be reading over the code that you write and then giving you friendly feedback.
Emphasis on the friendly part. You'll see.
Ajay is really nice. There's this convention you'll see that's just nit. That's short for nitpick, but it's like, can we like something small, but it's a nice way of saying things. There is a level of like don't be mean when you do this, because if you go into some GitHub repos and you go back as a pull request, you'll see some people being very ugly, and then they just get very defensive about their code. Nothing really gets done if you do that. But yeah, and so if we want to go further down here, sorry, I don't know if you want to take back over, but just looking further down, we see, okay, great. So these suggestions were made, and then these were carried out, remove to do and reduce font size, just what he said right there. And here's an example. And so it provides this very nice sort of linear history of, okay, this is where we start, I suggest this, okay, these changes were made, and so we can follow it top to bottom in the order that it happened. And it finally gets to a point where, okay, more changes requested, going back and forth. And then Ajay signs off on it. So he has approved this pull request, LGTM, that stands for looks good to me, great work. Ajay being very supportive of the code here, even nicer than most people. And now there's this option down here, changes approved, this branch has no conflicts. So these are sort of automatic checks done by GitHub. So the changes are approved because if we expand one approval, Ajay approved those, and this branch has no conflicts. This is a check that Git's doing. It's saying, okay, if I merge this code in with the base branch, which in this case is main, the base is what we're merging into, is this going to cause any issues? No, right now it can be done automatically. So now all that's left is to hit that button, and GitHub will actually go ahead and take care of putting that all together and essentially making a merge commit. I will not click that button.
Any questions on pull requests? All right, there's one other thing, if there's time, I would really like to show, because I think this is a really great tool and is also really helpful to visualize things. I'm going to go back to the repository that we made here as an example. So I'll go to my profile and whoa, no, not yet. All right, here. So this is the repository, right, that we worked on as a demo. We have file and second file. And there's this really cool feature which is hidden in a place that doesn't really make sense, and I don't know why. But if you go to this Insights tab, which you'd think would tell you about the, about analytics about your repository, which it does, but there's something hidden in here called the Network tab. And again, why it's called Network, I also have no idea. But this is really cool because it actually gives you a visual representation of your GitHub repository, just like the diagrams that we drew. So you can see here that we have two commits that when I highlight over it, it tells us what the commits are. I can, for example, click on the commit and you can see exactly the changes that have been made here, the commit message, etc. There's also, you can see here, the parent commit, and I think there's also a timestamp if you hover somewhere here. Yeah, 18 minutes ago. And you also have the branch here. So this is really, really cool because it allows you to see the history of your project and all of the different branches that are currently on GitHub. Now I'm going to show you one other thing, which hopefully this will not overwhelm you, but at the same time, I think this is really useful to see how far all of the things that we're talking about can really go. This here is the network tab. Now see if I can make this a little bit bigger. This is the network tab of the CSXL. So you can see here we have a main, which is what is considered to be uploaded to the internet. You can see we have different branches of people working on different features. For example, there's one for the TV screens that will hopefully be coming soon. And that will be for, in the Excel hallway, there'll be a nice display on the TV. There's other features that people are working on. But the cool thing is you can see, whoops, sorry, I did not mean to do that. You can see the history as we go back in time. So you can see these are all different, these are different commits that have been added onto this branch. But at some point, I think, yeah, you'll begin to see that there are a lot of these. And we actually cleaned this up. There used to be, I think, at least 20 going down because at some point there were up to 20 people working on this at the same time. But you can see that, yeah, I guess the only remnants of what was there is here. We cleaned everything up. But you can see how complicated our Git histories can get and how many people can be working on things at the same time. So if you're working on really large projects, you may end up with a Git repository that looks like this, with many different branches, with many different features. You can see certain things are being merged into each other, and people, you can see there's different people, like there's one person here, there's another person that are all working on different features simultaneously. And so that is why Git is so powerful and one of the most useful tools that you'll get to use throughout your time as a software engineer.
Or just computer scientists. It's used everywhere. Even the least software engineering applications will still probably use Git. So Good to know across all disciplines.
All right, I can. If you want to do the attendance check.
Sure, yeah. So there's an attendance check here. It says 10 minutes. I actually would like to go a little faster on this because I'd like some time to discuss some things, see what you guys have found. But yeah, pretty self-explanatory. Just hop on Gradescope real quick, partner up here if you want to discuss. Find an interesting repository, perhaps by well-known companies over 10K stars. If you find something that's really interesting that doesn't have 10K stars, I think that's fine too.
Also, since I forgot to show what stars are,
yeah.
if you go to any repository like the Excel, under code you'll see up here starred. You can see there's 9 stars. So as people see repositories that are really large that people are working on, you will have many stars. I think one great example is this one here. That there was a release. You do not have to know what this is, but you'll see here that this particular repository has over 24,000 stars, meaning that there are 24,000 people who have started, and therefore it's kind of saved so that they can very quickly access it. And so those are 4 much larger repositories that are more commonly used in the community. And feel free to also group up. The submission allows multiple people to be added to a submission. So if you're working with somebody, you can submit the same thing and just add both of your names on it, and that'll be fine. So it'll get around 5 minutes for this, maybe a little bit more.
If you're not quite done yet, that's all good. You can still fill stuff out, but like we said, just get it in. You're not this isn't being graded super harshly. Just wanted you to find something cool. But yeah, let's start going around. Anyone who found something interesting, anything off of here, just your project in general, just tell me something interesting. Feel free to volunteer. Yeah.
I used Flutter over the summer for an internship. I went to the Flutter repository.
Flutter,
Yeah.
great, yeah. Do you want to explain in a sentence what Flutter is?
So when you want to build apps, it's easier to use previously existing kits. So Flutter is a kit built on top of another programming language called Dart. It just makes it easier to make front ends.
Yeah, great explanation. I think another powerful part is that it lets you write the app once and deploy to any platform, right?
Yeah, cross-platform.
Yeah, cross-platform. So write one time and then you have an iOS and Android app. Fun stuff. Anybody else? Any cool? Let's hear something from this side of the room. Yeah. Awesome. Faker, yeah, I don't know if everyone heard that, but a Python package that lets you generate fake data to test your Python packages on. That's great. So fake names and stuff, is that, yeah, that is actually a big pain point sometimes, generating fake data to test. Well, great, yeah, I'm glad you guys found some stuff. We'll look through submissions too. Hopefully you found something cool, something that you think you can use. Because that brings me to this next sort of talking point. And this is generally, you've maybe heard this term before, open source. Who's heard of this? Who knows what open source means? Okay, this is great. Not many people. Open source just means that the source code, the code for whatever project it is open, meaning anybody can read it, anybody can take it, adopt it, use it however they want, but just that the code is public. That's it. When you read open source, just think public code. I can look at the code, I can see exactly how this piece of software works. And this is in contrast to what's called closed source, which is software that code that has been written that you probably use that you cannot see the source code for. And this seems kind of counterintuitive at first if you just think of it, if you're thinking of it at the level of Python, right? Well, to run any Python, I need the Python files. So how could it be closed source? How can I not know the source code? But this is more in situations where you download a program that's pre-made for your computer essentially. So if you think Microsoft Word, something like that, that is made, Microsoft codes that, and then they do this step called compiling, which basically just turns it into code that directly runs on your computer. That's essentially code for your processor. So it's not easily human readable at all. That's what we mean by closed source. So everything that you find on GitHub, anything that you're able to search for, is open source. Just inherently you can see it. Code is publicly available and anyone can contribute to it. That is a big thing. The open source, it's not just, it is at its base level just a descriptor of the code. Is it open, is it closed? But it's also, you'll see a very big community in that open source software sort of has this ethos of come use the code. If you see anything that could be improved or you want to add a feature that you think other people could use, contribute. Go ahead and write that code. And just as we saw on GitHub, you write the code and then you make a pull request for it on GitHub. Say, okay, I just made this feature. What do you guys think? Do you want to merge it in? And this is sort of how a lot of code evolves over time. You'll see rarely are any of these one things sort of built by a single person and maintained by them. Other people come in over time, they add bits and pieces, and sort of you leave your mark on stuff, which is pretty cool. If you had something to add.
Yeah, one cool one that I found like a few days ago is actually, let me see if I can find it here. Let's see. Yes, so the official Wikipedia app actually for iPhone is open source. So this is all the code that makes the Wikipedia app work. So this is another example of a pretty cool, this is written in the Swift programming language, my favorite. I know Noah disagrees. And there'll be some, we'll be talking actually in a few weeks about all the different programming languages and all these different types of projects you can do. But this is an example. You can see there are 116 different people who are contributing to this project. And right, they have releases, all the code is public. You can literally go into anything here. Like there's this, you can see every icon is available. And it's something cool because, this is something that you would think, okay, well, maybe only websites or maybe only these small little programs are open source. No, there are large programs, including like an entire app that's on the App Store that can also be open source. So this is really cool, and it gives you a lot of different ways to potentially contribute to such projects.
Yeah, and to go off of that, you'll see not only is like software that you're using every day open source, but basically across any discipline that requires even a little bit of coding, there's probably open source stuff. So if you think, right, software engineering, right, here you go, here's an app, they're perfect example. Cybersecurity, there's situations where people are writing code to exploit vulnerabilities in certain hardware and stuff. They also typically share this through GitHub. You can go on there, see that code. AI especially. There's some other sites that are, sort of play a role, but like, foundational, I'll actually open up, I think, llama.cpp is that just needs to search that in GitHub generally. For anyone familiar with AI, Llama is like the big like open source language model. Here, 65.4K stars, and this is like bleeding edge AI stuff. And it's all open source, meaning that anyone can come in, they can contribute. It sort of helps the software grow. And in case you couldn't tell, I'm a big fan of it because it's very beneficial. Everyone eats when the software is open source. And I'd like to contrast that in a second one big example of closed source is like if you have an iPhone right now. The software that runs on there, iOS, is closed source. I can't get in there, right? I cannot see the iOS source code. Apple controls that and they send it to my phone. I have no control over it, which personally really irks me. I really don't like that. I think that if you have a device, you should be able to control what runs on it, right? I'm not saying Apple has to share their source code, but at least give me the option of running my own. They lock it down a lot. But so you see sort of this warring faction between open source, which is what powers actually a lot of the internet. Any server that you go to is almost certainly, unless it's Windows powered, open source. A lot of apps themselves, like the Wikipedia one, open source. And so I want to ask very quickly, just a general idea here. What do you think the benefit of open source is versus closed source? Anything that I didn't touch on? And what do you think the benefit of closed source could be over open source? Because there are arguments to be made for closed source software, especially if you think of it from like a cybersecurity sort of standpoint of like hacking into stuff. Just very quickly, does anyone have a thought off the top of their head? Yeah.
You've got like longevity and kind of community support. You get a lot of programs or a lot of things that drop by various companies. If it's owned open source, it can be continued or maintained.
That is a great point. Yeah, the longevity point of code. So, right, if a company makes closed source code and then they decide to stop supporting the project, which Google actually does a lot, you'll notice, well, okay, I'm out of luck. I was just using this whole thing. I built my whole business around it. Now what do I do? But you're right, when it's open source, people can come over, take over, maintain it, stuff like that. So, and one other point, sorry, let me be very quick on this. Closed source, it comes into play a lot with cybersecurity, which I mentioned, that closed source, right, you can't see the source code. So in a way, it's secure because you don't know what's happening, so it's really hard to hack it. But on the flip side, once hackers can like find stuff in there, people who are like good hackers who are trying to find like good ways of protecting stuff, they don't have access to the source code, so they're not going to pay attention to it as much. So when hackers do find a way to get into some sort of closed source piece of software, it's not really combated by the good guys at all. Whereas if it's open source, everyone can see the software. It's usually the good guys getting into it first, so stuff is really secure. in that sense. And sorry, we're at time, but Jay's going to be very quick here.
Yes, this is something that'll take 30 seconds since we're running late here. But this is one last slide, and this is actually going to lead us into the next assignment and also the first discussion and project that we'll be doing tomorrow next week in class. That is the GitHub profile. So as you know, GitHub, right? There's so many different developers on there that it's almost kind of like a platform for developers to also share what they're working on, talk to each other, etc. And what you all are going to be doing in the next assignment, which is also one of the official GitHub ones, is designing your very own profile page. So I'll just go to mine real quick. I kind of added to it for example for this class. But you can customize your page to talk about, for example, projects you've done, such as apps, different tools that you have used or that you know. Thing about you. You can provide different links here. You can also see down at the bottom, here's some pinned repositories of repositories that I have worked on quite a bit. You can actually also see contributions. So these are the number of. Wow, that's kind of sad to think about, actually.
That's awesome. What do you mean?
Well,
Round of applause at Jay. Wow.
But yeah, there are 9,000 or so commits in the last year. Most of them, I guess, happened in November and December. So yeah, there's two different ways to look at that. But this is great because you can see, this is a way to showcase your work. And the assignment for this week is going to be creating your very own. And since we didn't have time to really talk about it as much today, I'm going to send out more detailed instructions later. So keep on lookout for that. If you have questions, feel free to catch us. We'll be hosting office hours tomorrow, I think.